Question 18. Let's go ahead and discuss this, how I would go about this. So it's a word problem. What I do is I'm just going to focus on a few things to start off with before I even start reading. So I see there is this, there's a formula, T of H 48.5 minus, so this is a linear formula. So H is an input, T is an output. So I kind of look at that. And before I go to read too much, I kind of look at the questions. So it looks like they're going to want us to find the inverse function. That's t to the minus 1. That's an inverse function. So we're going to need to find the inverse function, then we'll find it at 33. We've got to answer some kind of statement here, and they've got, talking about temperature and Celsius and stuff. So let's see, I guess it's about time. I looked over this, and let's go ahead and start reading now. So scientists have found a relationship between the temperature and the height. So T for temperature and height above a distant planet's surface, T of H. So H is height, T is temperature. Given below is the temperature in Celsius of a height h kilometers, so we know we're in kilometers, above the planet's surface. The relationship is as follows. So I guess the higher you go, this is negative, so the temperature gets colder. So complete this statement. Okay. Let t inverse be the inverse function of t. Let x be the output of the function t. What is x? That is, x is t of h, and h is t is the inverse of x. Maybe a little bit overly. Which statement best describes t inverse? Well, before I go trying to describe t inverse, I don't know, I'm going to have to find the inverse. Why don't we go ahead and do that part, and then maybe this will all make sense. So how do we find an inverse function? Well, think of this function notation. I guess we do it in terms of x and y. So the thing is, they're going to use x over here. The inverse function, x equals t of h. Anyway, so t of h is x according to this part here, and that's going to be equal to 48.5 minus 2.5h. To find the inverse, what the inverse does is it changes the input and the output. It swaps them. So we're going to do that. We're going to swap it, and then we're going to solve for the missing variable, I guess. Right. X equals t of h. And then we're going to solve for h, and that will give us our inverse function. Okay, so solving for h, we're going to subtract 48.5 from both sides, because 2.5 is multiplied times h. So then we get x minus 48.5 is equal to negative 2.5h. And to get h by itself, we're going to divide by 2.5, or negative 2.5. And we divide this whole side by negative 2.5. Okay, so we end up with, well, let's just leave it like it is. H is on this side, right? These guys cancel. And we have x minus 48.5 over negative 2.5. I should accept it that way. Usually to make things cleaner, we would bring this negative to the top and distribute it through, so the x would become negative, that would become positive, the 48. So another alternative way to write this is move the negative upstairs. We'll get a negative x, we'll get a positive 48, so we're going to put the 48 first. 48.5 2.5. We're going to subtract x from it, and then we're going to divide by 2.5. Now again, I think it'll accept either one. This is our h. It's also what we call the inverse function that has an input of x, as you can see here. X is the input. X is a temperature, right? So, and h is a height. Why don't they just use t? I don't know. So 48.5 minus x, and then we're going to highlight it, make it into a fraction, and we'll put 2.5. It seems easiest right now. I could plug in 33 for x. This is what this one's, the C part's asking. So let's go ahead and do that. We want to find, let's change color. We want to find the inverse function at 33. So that's the x. So we're going to plug that in here. 48.5 minus 33 divided by 2.5. Okay, 48 minus 33 is going to be, that's like 18. 3 from 8 is 15. 15.5. So subtracting, divided by 2.5. See, I think I've got a calculator here somewhere. I got that one. Don't know if it works. Let's find out. I guess it doesn't. It's having this. Anyway, I think my subscription ran out or something. So let's just use a regular calculator over here and put that down. So what happened to all my work? 48.5 minus 33, 15.5 divided by 2.5, 6.2. Okay, so we'll just go ahead and put that in there. Took away all my work as well. Okay, but we've got it recorded here. So now, which statement does, okay, the ratio of the temperature in degrees Celsius to the number of kilometers T, so best describes T. It's a ratio of temperature to numbers of kilometers X. Well, no, because we know X, kilometers X, no, X is not kilometers, X is a temperature. X is a temperature, H is in kilometers, H is a height. The height above the surface in kilometers where the temperature is X degrees. Now that's, I think that's what I'm going to do it, but let's keep reading. The reciprocal of the temperature in degrees Celsius at a height of X kilometers. Well, no, that can't, X is not kilometers, X is temperature. The temperature in degrees Celsius at a height of X kilometers. No, so just looking at this, you know, the fact that we know X is not kilometers, X is a temperature. That's what we have to make sure of. None of these three can even be right. So we've only got this one here, this one we've got marked. So hopefully that all helps. That was 17. 18. That was 18. Sorry about that.